Can you hear me?
Yes, I can hear you. Hello?
Hello. It is
Hello?
audible. It is audible, Karthik.
I'm audible. Okay. Thank you, sir.
Yeah.
So I hope my screen is also visible. Can you confirm?
The screen I'm not visible. It is not visible. Your audio is clear. Now it is loading.
Okay. So screen is coming up, sir.
Yeah.
Right. So we can start. Students
Yeah.
can
Sure.
see
Sure.
me. Yes. Thank you very much, sir. So, hello, students. As I was telling in just a while ago, today in this class we would be starting with programming in Python, basics of Python. We would see how much we go about in this session, and then we will be looking at Raspberry Pi, its intricacies, how to interface it, how to interact with Raspberry Pi to couple it with some kind of hardware. Those things we will be looking at in the tomorrow's session. So coming to Python, right? So what exactly is Python? We all know that it is a programming language, but why is it suggestive to learn Python? We already have Java, we already have C, C++, which we have been learning. Like, what is so special about Python? The thing is, Python is a very easy to learn language. It's high level language which is very close to the language that we speak, that is English. We can write code like paragraphs of English language that it's nearly, not exactly, but nearly paragraphs of English what we write. We can somewhere close write program close to that, right? And the length of the code is much shorter compared to Java and C++. I in fact have a slide showing the example, so I would be showing it to you, the example of it. And you can actually start learning programming by starting with Python, because as I said, it is very close to English language. You can grasp it very easily, and you can do a lot of projects using Raspberry Pi. With that, you can solve a lot of real world problems. You can use real world applications. You can control your room light, or you can control your fan, or you can control some kind of your CC camera in your institute, these kind of things, using programming language Python, coupling it with Raspberry Pi, right? And another reason why you should be learning Python is that the rising demand. Almost all companies, tech-based, are into Python. They are using Python extensively. The beauty of it is it's open source. Nobody exactly owns Python. We know Java is owned by someone like this, and it's object-oriented, procedural, and functional language. You can use it as also as a scripting language, where you can use to do some kind of DB connectivity, web development. It doesn't just sits at one way. You can't just use it to program some kind of a front end application, or you can't just use it to script it in main like PHP to connect it with the DB, this kind of thing. Python can sit in wide plethora of applications, right? So that is where Python trumps over the other languages. So the most and the main important reason why you should be learning Python is that it's being adopted by many tech companies. Number one aspect. Number two is it's very very simple to learn. It's like any other programming language. If you persist and practice, you would ace it in Python. That is for sure. Right now, how simple is it? This is a typical comparison of Java code with C code and a Python code. Right. So a small hello world program. C program, we write hash include stdio.h. In the main, we write print hello world. But in Java, we define a class and then a function, and then we put sysout, println, and then hello world. Right. However, in Python, is just one line, print hello world. You don't have to input anything. You don't have to define a function. It's just one line of code. It's that simple when you compare in terms of the length of the code with respect to Java and C. Right, Python is that very simple. And as I said, plethora of applications. Python is used for web development, gaming, graphics, and even for scientific applications, environmental research, space research, weather stations, etc. It's quite simpler and it's quite efficient in terms of its capability. That's why it has plethora of applications, and that's why it's a strong recommender for you guys to learn Python. Evolution. How did actually Python start? Python was actually the person who started it is called Guido van Rossum. As a looking at the name, it's a common perception that Python is named after a kind of a snake, right? But actually, no. It started. He started it. Because of a circus show, Monty Python show. He was reading some kind of a published scripts from the Monty Python's Flying Circus. Right, it is basically a comedy series, and in BBC, he was looking at the script, and that went on to motivate him to name it Python, because like the script, the language was short, unique, and slightly mysterious. Right, that was aligning with the Monty Python show. That's why he went on to name the language that he was creating also as Python. Right, it has almost all features derived from different various languages that we know. Some features are taken from C, some features are taken from Java, C++. The best of all have been embedded into the Python. And as I said earlier, it is open source. It covers under GNU public license, so you can also add libraries, public libraries, and contribute to develop Python. So that's more beauty of Python. You can also contribute to improve Python language. And Python versions, when it was started, today the version that we have is 3.0 or 3.x, what we call is. Right now we have 3.10, stable version is 3.9, I suppose. So the 3 family is the current version that has been used. There were a lot of improvements, features. The language evolved from 1991. Initially, there was exception handling. There were like functions, some kind of data structures were there. And eventually, functional programming tools were added. Then list comprehensions were added. Garbage collection was added. Support for Unicode was added, and things like that went on to add. And you know Python 3.0 is most stable version right now, and syntactically also some evolution took place. If you had learned Python in, for example, Python 2.0, some syntax changes would be there when you try to program the same logic under Python 3.0. So I would suggest you to stick to Python 3.0, because almost these versions, the older versions, have become extinct, and not many applications support these. So better to learn this and then continue with this. So you would not even have the confusions around Python. And Python, as I said, is a high-level language, and it is an interpreted language. Interpreted language, it's not a compiled language. Meaning to say, so Python, if you write a code, C code, right? What your compiler does is, once you write the complete code and pass it to compiler, your compiler evaluates all the lines in the code, right? And at the end tells you it's good to go to execute, or it even executes, or if there are errors, it gives you all errors in a consolidated way. As in line number 3, you have an error. This error, a semicolon was expected. Line number 10, you have bracket closing was expected. Line number 20, you have this kind of error. You get all of them together because your compiler passes through the code all at once, right? However, if it's your Python, then your Python is actually an interpreted language. Now, if this is your Python code, then you actually interpret this, meaning you execute them line by line. Your Python doesn't scan all lines and then process them all together one after the other, but your Python first tries to check this line whether it is correct or not. If yes, it executes it. If no, it throws you an error saying, look, there is an error in this line. So you would not know what are the errors in the line coming, below this line. You will have to fix this line's error and then move ahead. Basically, the processing here happens line by line, and execution takes place line by line. And it's interactive. You can run a Python line by line, not like scripted way, as in if you have hundreds of lines together, you can run all of them together at once as a script, or you can also run one line by line and get intermediate results per every line. And it is an object-oriented programming language. You guys would have already, if you're in HM now, would have studied object-oriented languages, or object-oriented paradigm. What are the advantages of it? How useful it is, right? So this statement covers all the features of Python in one line. Python is a high-level, interpreted, interactive, object-oriented programming language. So this is basically Python for you. Some other features are, when you set on to learn Python, you would look at it. But other main reason why Python is used, right, extensively, Python is not just used to couple with Raspberry Pi kind of devices. Even today's emerging fields like AI, we use Python a lot. That is because of extensive standard libraries, right? For example, if you want to do some repetitive tasks, let's take that some kind of you have a convolutional neural network where if you have an image and you want to convolute, instead of writing a C code which has for loops, taking a filter and convoluting image pixel by pixel, you can just pass this image and the filter onto a function, an API, and it will give the result of convolution. So there are because it's open source, a lot of community contributions have happened to this language, and extensive support of libraries are available, where these libraries help you to solve a lot of problems, data analysis, machine learning, AI libraries to do hardware interfacing, libraries to do graphics. All these kind of different libraries are available, and there are options in these also. For example, you can build GUI using Python, using 3-4 different types of libraries, right? There are 3-4 different libraries which helps you to design graphics, UI for a Python application. You don't really have to rely on one standard library. You can install and import a different library and change the way you use it. You can do that, and it is cross-platform compatible. You can run a Python program written in a platform on a different platform, right? The written in a Python program written in a Linux system can be run on a Windows system, and the other way around. It's portable, extendable. You can connect to databases, do GUI programming. You can use it to scale, and it performs dynamic semantics, and automatic garbage collection happens automatically in Python. You don't have to write garbage collectors or cleanup statements to collect the garbage once you have used all the memory. Now that's about why you should learn Python, and what is Python, and why, how simple is it is. And it was just some couple of slides to let you know how good is Python. And right now I would be showing you the installation of the Python. I have already installed it, but would be showing it to you anyway. So if you go to python.org, that's the official Python website. uh, So you end up in a page like this, where you have a lot of standard materials to learn Python, to learn intricacies of Python, and etc. And here, to install Python, in all this you can see different releases, what are the Python related events and all that. Go to downloads, and you can download the latest version. 3.9 is the stable version that we have, but it doesn't run on Windows 7 or earlier version of Windows. If you're looking for Windows, it automatically detected that my OS is Windows, and it suggested. If not, you can just click on the view full list of downloads here, and it shows you different releases. Depending on what OS you have, you can select the OS here, Windows or Linux or Mac or other. So I have Windows, so I'll click Windows. Here you would see a lot of stable versions as well as pre-release versions. Python 3.10 is under pre-release version. It is not a stable version yet. A lot of improvements are happening under Python 3.10. But we already have a stable version which was released in May 3rd of this year, like last month, which is Python 3.9.5. You can download this, but as I said, it doesn't support Windows 7 or earlier versions. So I will have Windows, Python 3.8, because I have Windows 7. I wanted my Python to support my OS, so be supported by my OS. So I will go for this. This doesn't run on Windows XP or earlier. Mine came after my Windows 7 is the next version of Windows XP. So I'm going to download this depending on 32-bit or 64-bit. I have already downloaded it, so I would not be, clicking on it. You can click this Windows installer, 32-bit or 64-bit, depending on your type of operating system what you have, the word size. You can go for the version also. If you are using Windows 8 or Windows 10, then you can go for 3.9.5, which is later version. Once you download this, I already have it downloaded here. So I will run it. So it shows me whether I have to run it or not. I would say yes. One important step here is to, you see, yeah, This says, as soon as I click on it, it says install Python. It gives some kind of path where it will be installed. You don't have to change it actually. You can go next, or you can change custom location by clicking on this. One important thing is add Python 3.8 to path. You people have to click on this, check this. So by doing this, you can use your command prompt also as your Python interpreter, and you can run any program Python file in your command prompt, like a normal, a GCC compiler, how you do from command prompt. Same way you can run Python interpreter in your command prompt in both interpreter mode or in a scripting mode. I'll show what these two modes are. You have to check these. You have to select this and then click install. This takes you to install. You don't have to change anything. Next, 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 and finish, and that installs your Python, right? So I'm going to cancel it because I have already installed it. I just wanted to show you that you have to select this add Python to path. You must select this. If you don't select this, what happens is you will not be able to run Python command on your command prompt. Then you will have to again go through the pain of configuring the environment variable, adding the path into the environment variable, and those kind of things, right? So you must select this Python path. Okay. So once we install that, what we do next, and you will see a folder like this, Python 3.6. Here you can select any of these interpreters. This ideally is an Python IDE inbuilt in use to write your Python programs and run it. This is Python. Need this can be used, or what you can do is you just go to CMD, that is the normal command prompt. Since I have added my command, Python path to the environment variables while installation, I have selected add Python to the path option. I can basically run an Python interpreter here by just typing Python. I'll just type Python, and it takes you through the Python shell. It says Python version, which is and things like that. You can type here, and it shows you what kind of you need. You can interact with it. For example, I will tell help string. It shows me object I have to pass. Is equal to so I can go using I kind of utilities used with string. So under string, what all can I do? I can use what the functions that are pre-built that I can use this kind of stuff. See, if not, I can just run it, some program. So Python, it shows me shell. I'll just write print double quote hello world. This gives me the output hello world, right? It's that simple. You can just install it and then go to command prompt, type Python. You should be able to get a shell like this with 3 arrows, right? Here you can type any kind of any Python statement. A is equal to 1 plus 2 I will give. Then I will select print A and it prints 3. See, I don't really have to declare what is A, what is data type of A. I didn't really have to do anything. It automatically took the data type and everything, and it calculated and it gave me the output when I printed A. Right? So Python is. I hope installation is pretty clear. I'm moving forward here unless you guys have any questions. If you have any questions, please feel free to it and let me know. Python. Look, let me the two versions of Python that I shall show and Python. Uh, in Python, let's say there are 2 lines here. I have to do A is equal to 1 plus 2 and then enter. Right now, A is equal to an variable called A was created. 1 and 2 were added and then they were assigned to A, and all this execution happened without any error, right? So if I give A is equal to 1 plus, I get an error right there that there is the syntax is not matching because it could not execute that line. So as soon as I do A is equal to 1 plus 2, it executed it. And then I will write print A. The thing is here, I have to wait for every line's output to be, every line to be executed and then write the next line. If you have 4 lines, 5 lines, then that's not a problem to do. But if you have hundreds of lines, then that is not ideally, suggestive. It frustrates, right? You don't want to obviously write a line, then enter, see if that is correct, syntactically right, then go to next line, see the output of it, then go to next line, see the output of it. You don't want this to do. This is called as interpreter mode. Right now, what we are doing is called as interpreter mode, where you are actually executing the Python code line by line and seeing the output of it line by line. Right now, what if you don't want to execute it in interpreter mode? What if you want to, you have a huge monolithic program, you have a huge logic, and you want that logic to be executed all at once. You want to write a function for that logic and you want to be executed at once. For that, what you can do is I'll give exit. I'll be out of the command prompt in Python shell. If I give exit, this 3 line goes and I get my C:\users slash GCR. That's my desktop, my system. Basically, I am out from the Windows command prompt. Right? What I can, apart from this, do is I can just go anywhere in my system, create a file, call it, uh, Python program, and the format of Python script is .py. Here, this is a text file. I will have to replace it with .py. Right? If I replace, it will ask you whether you want to change the extension of the file. You have to give yes. As soon as you give yes, you can see here you can see here that some kind of logo has appeared. See, the Python logo automatically appeared as soon as you change the the file type to .py. Now here you can right click, edit it with idle. This is one way of opening a Python script file and then writing the program. Other way is you can directly go to here ideally, right, and then print. Just giving some kind of a name, and then you can save it. So Control S, it asks me where do you want to save. So I will tell it in my, yes, I want to save it as my second PY program, and automatically the type. So I will have two types of files created here. So I have Python first Python program and the second Python program .py, two files created in different. One thing I just went on to new here, selected test document, change to the format from .exe to py. That way I can create a file. The other way is I can go to idle here and create a new file, a Python file here, a new file, and you can save it. That also creates a Python file. So if you see here, if I open it with idle in the second Py program, I had saved print high. I can have it here. Right? In the first Python program, what I will do is I will write these commands, these code equal to 1 plus 2, and then print a. That's it, right? And I will save it. And here I have to go to the path where the file is present. My file is present in the desktop in a folder called as programs. So here you see C users GCR desktop programs is the path. So I'm already at the GCR, so I go inside my desktop and then CD programs. So here I have my files. So once I'm at this part of the file, I can just type Python. Python is the command for calling the Python interpreter. Give a space and give the name of the script, which is first Python program .py. If I execute this, I will get 3 as my output. 3 is my output. It executes the line of code that was present here. You can actually change it here to 5. Then I will save it. I have saved it. I will go here and get my output to 6. Right? You can change the code. You can get to see the output. Whereas in the interpreter mode, you don't have the liberty to go back and change the code. Once you go, if you want to get the success part of your result to print A, you have to go to the shell again. You do A is equal to the file, and again you have to do print A. So you have to re-execute mode. This is called as a scripting mode. When you want to execute a monolithic programming logic all at once, then you go for this script mode. If you just want to try a line or a command in your Python and try and understand how it behaves, then you can go for interpreter mode. So both ways you can basically look at it, execute Python. Then let's get started with Python basics. The very first thing that we're going to learn is how to use commands in Python. How do we use commands in C language? You guys would have already learned it in your first year. In C language, we use comment by using double quote or double slash or slash star, then ending with star slash, right? single line and double line, multiple line comments. In Python, we are going to have a single line comment using hash. Hash gives me a single line comment. So I can give here hash. This is a comment line. You can note the change in color, indicating that this is a command line. And I can go to command prompt, cd desktop, and I don't get to see the comment. Right? This is how we do a single line comment. Comment is done using triple single quote or triple double quote. And we'll give like here. So you know the basic programming paradigms, right? So we write author date 2021. Right. If you see here, E is given in a different color. I know why it is, right? These are lines. I can either make them three single line, comments, or I can make them multiple line comments by putting them under three single quotes or three double quotes. You can see the change in color here. Unless I close it, even these two lines are in green. These two lines are also considered as comment. See, this is a comment. Now I go and execute. In C6, I don't see this, right? So this is how you do multiple line comments. Then you can also have multi-line, statements. So multi-line statements can be given as by giving, for example, here you see it's given as R is equal to, this is basically 8 plus 5 star slash, sorry, there's no slash here. 2 plus 9 by 5. This is the expression that is being evaluated to store in R, but you are writing it in multiple lines. So you are writing it in multiple lines by ending each line before you terminate the statement with a backslash. This backslash character, right, allows you to break a statement or break a line in Python into multiple line statements, right? That is one way of doing it. The other way is there are some data structures in Python which uses different types of brackets like this, square brackets, then this floor brackets, right? When you have some data in this brackets, you don't really have to give a backslash to span this line across multiple lines. You can just open it here, go on writing it, give a comma, go to next line until you close it. It considers it as multiple line, single entity, right? Single statement. Until you close this, it is considered to be a single statement. So that way also you can write multiple line statements in Python. Single statement is being split into multiple lines. Then comes the two important aspects of any programming language: how to give an output, how to take an input. How do you take user input? How do you give output to user? Giving output to user, of course, in C we have printf, in Java we have system.print.ln. Then in Python you have a statement called print statement. This print statement has it prints whatever you give in either single quote or double quote. Right. You can also have percentage %f, the format specifiers, percentage %d, these format specifiers, to give the output values, to supply the values in the print statement. So for example, here if you see, the last Python version is %d. Then in C program, what you do is you give printf the latest Python version is %d, comma, you just give the value, it is 3, or you give the variable a, right? But here what you have to do is, you don't have any comma to be given in Python, and you don't have f in the printf. You just give a space after the double quote ends, then give percentage, what is the d stands for, what d should be replaced with, percentage 3. Percentage 3 will replace d with 3, a floating point, integer number. If you give 3.5, it takes only 3. The reason is you have given integer to be the format specifier. If you use f, then it would have given 3.5. So like that, that's some similarity in C program print statement, but they are a little different. So format specification, they do have some kind of precision bound that you can give. Here 5.3, what is given means that you have 3 values to be displayed. You have total 5 digits to be displayed, and 3 should be after decimal point. So you don't have there are 2, you don't have 2 digits before decimal point. That's why though you have 5, you will be able to only display 2, one element before decimal point. You will be able to display only 4 digits, 3 digits after decimal and 1 digits before decimal. If you would have had 13.1417, you would have seen 13.142 approximated to the nearest value here. Like this, you can give format specifier. Giving 5.2 means 5 values, 2 after decimal. So 2 after decimal, you can see it, right? So this is one way to print. You can print a variable also. Here what we have printed is variable. A is taken to be variable. You can print a string directly, the content, the value of A is colon %d. Then I have %A. Value of A is 6. So the value of A is replaced with the %d in an integer pattern, right? So you can display like this as well. So that's about print. Then comes user input. How do I take input? In C, of course, we know how to get CS, get as, scanf kind of functions, but in Python, we use a function called input, right? I'll show you with the demo, and then we will go with let's say A is equal to input, B is equal to input. As I said, I don't really have to in Python declare the data type of a variable. I will tell you about it later part when we look at a variable in detail. But for now, just understand that in uh, Python, you don't really have to declare a variable and tell what is the data type of it. You just go on assigning whatever you want to assign to any variable name that you have to take. C is equal to A plus B, and then I will give print the sum is percentage B percentage C. I do this. If you see here, it is not giving me any input, but there is a blinking cursor. What is this blinking cursor doing? It basically is expecting me to give an input so that it will assign it to A. So I will give here 2. Then again, one more line is blinking. What is it? It is this input, second line. You are expecting B, value to B, right? So let me give this as 3. And then it will execute C is equal to A plus B and print it. There is an error here. I'll come to this part. So one sec. Just give me a moment. I'll tell you what this is. There is a small error to be dealt with. Let me tell you this data. 2, 3, and the output. The sum is 5. So it told me what the output is. Right? So how do I take in user input? I can also give it like this. Input. The value given by user is percentage S. Hello. Yeah. The value given by user is hello world. It prints without any error. Basically, input is used to take user input. Now, generally in C program or any other language, what we do is we first print, like, see, whenever you go to ATM, if your ATM just starts blinking in front of you, you understand that you have to enter a number, you have to enter whether you have to enter your PIN or whether you want to enter how much amount you are taking, or in SBI's it asks you to enter some number so that you can see whether you are able to see the number or not. Some kind of testing the screen happens there. Until and unless you display what input you are seeking, user would know when you are that's a good programming style, right? You ask your user what you are expecting. You don't just blindly blink and understand, or simply wait for user to understand what the user application is expecting and enter it accordingly. You being a good programmer must see what the input you have to get. So what you do, enter some, this, and you like this. Your program understands. It won't just blink here without this statement. You don't know what it is. What you want to do is just your ATM starts to, right? Should enter on or should enter pin. Some ATM count first and then ask the pin. Some ATM ask more. So you don't know what you are expecting unless you ask for it, right? That's a good what a good programmer would do, a good application. So now, no, okay, now it prints. The value given by user is what's up, right? Whatever you have given. So what I am trying to establish here is it's always size of max. And then you, right, like that, you will have to give a statement. The thing is, you don't really have to add print statement here extra. Instead, you can pass the statement that has to be displayed as a parameter inside. This is the job. Input, if you pass something and it starts the user to give value. And here it's a value given by user, right? So that's a so name input enter name. It shows enter your name and then starts blinking, expecting user to enter the name. As soon as you enter the name, it is assigned to a variable called name, and you are printing. Welcome to the session on programming in Python. The name, for example. So that's input is a function, and this function captures user input and always returns string as the output. For example, see here. A is equal to put it asks me to enter something. I give 10. Now, if I print A, what does A have? If you look at what is the data type of A? It says A has 10, but it belongs to str string. Basically, what is where did A get 10 from? It got 10 from input. Input accepted 10 as the input from the command prompt. It gave it came and assigned to variable called A, and the value that it assigned was a string variable. Now, if you want you must type must convert the type of the value that has been inputted to the second. I will give C equal to A plus and then I will just hold on for a moment, please. Hi, sorry about that. So I hear that my voice is breaking. So could you please confirm me if my voice is not breaking now? All right. So I guess Shubhashini ma'am told me that my voice is clear now. So continuing here, let's say I want to print C here. I'll just print C. Right? It takes two numbers and gives me the sum of it. It's pretty straightforward, right? Let me exit the interpreter mode and go to my program and execute Python first Python program. It's asking me enter first number, I give 10, enter second number, I give 20, it gives me 1020. What happened here? Basically, it performed addition between 10 and 20 as string, plus in Python, between two string elements will concatenate the strings. So 10 and 20 got concatenated. It didn't get added. So it was my responsibility as a programmer to typecast it. How do I typecast it? Int is a function which converts a numeric value, which is string, into a integer value, a string numeric value, a string literal, which is a number, into a numeric value. It converts it, right? So I have to pass this input output to int. So I will call int, open bracket, close bracket here. So basically I am taking the value 10, input returns it to int converts it into number, and then assigns it to 10. Now if you see, if I give 10 and 20, it gives me 30 as my output, right? Now, if we look at the type, let's say A is equal to int of input. It asks me value, I'll give 10. If I give type of A, it tells me A is of type integer. A was assigned with 10, and if I print A, it gives me 10, which is integer. But if I execute this without int, casting, even if I give the same value 10, and if I give type of A, it says str. If I print A, it still gives me 10, but the type is different. So the operations which applies on this variable will differ. If I apply plus, if it was of type integer, it would add. If it was of type string, it would concatenate. Thereby, you should have extreme care. There is no other way you can know what is the data type unless you verify it, right? So you must take extreme care in Python while you are dealing with the type of the variables which you are assigning after the content is been read from the user, right? So if the data is taken from the user and if you want to assign it to a variable, you must take extreme care to convert it to appropriate data type before you assign it. So that's one small thing that you have to take care of in Python when you're using input. See, I am taking enter a number, 23.4 is given, print n into 2. So basically math application, 23.4 into 2 should have happened. Into is basically a repetition function on strings. So you see string is being repeated twice. Plus is concatenation, into is repetition. So you got the same string replicated twice. Instead of multiplying 2, 46.8, instead of getting that, you got 23.4, 23.4 twice, right? You have taken it as a string. Then I'll skip this. I showed you how to execute the Python program in the skip mode, so I'll be skipping this thing. Let's move ahead to data variables. Now, the variables in Python can be differentiated into identifiers, variables, data types, and operators. These are the elements of our Python program. Out of that, when we look at identifiers are basically the names that you give in the program to identify something. It can be a variable name, it can be a function name, it can be a class name, it can be an object name, anything. It's just the user that you are giving the name to it to identify something, right? So it helps you. The identifier name should always make sense to you, the programmer, so that after a couple of years, if you come and look at that program, you should be able to understand it. So always your program should be well documented, that is well commented, all comments should be proper, and the name of the variable should be used properly, right? And you can basically start a variable in Python using an underscore or a upper letter or a lowercase letter, and the variable can have digit, but they cannot start with a number, right? And you should not have identifiers as Python's reserve words. Reserve words means keywords in C, right? So there are some words which are used to do some activities in your Python. So you should not use those reserve words because they are meant to do something. For example, while. While means it's loop, right? We know already. If is a programming construct which is used to check condition and then branch out the logic flow. So if you can't use, if is a reserve word in Python, you can't use it for identifier. You can't use it as a function name or a variable name or an object name. And they are case sensitive, right? So you can have two variables with different cases of same name. Variable names can be arbitrarily long. They can contain mixture of underscores, uppercase letters, lowercase letters, and numbers. But it is very important to start with to note that they cannot start with numbers. Right? Though you can start a variable with uppercase letter, that's not really a good way of programming. So always a good way of programming is variable names, especially. We are not talking about just identifiers. Variable names should be in a smaller case letter. They should be readable. All words should be separated by underscore. There is no white space that you can entertain in it. So for example, if you have some variables like bill ID, you give bill underscore ID to identify it, customer underscore ID, bill underscore amount, kind of a declaration. Though it's not a hard and fast rule, you can use variable names as A, B, C for these three. That's not a problem, but it's not a good programming practice. That's the whole of it. Right now, so let's have a look at a small programming demo of initializing the variables given here and then printing them. So we would want to initialize bill ID to 1001, customer ID to 101, bill amount to 199.9, and then display them accordingly, right? So let's quickly write a Python program for that. So I'm going to edit my first Python program file itself. So variable name bill underscore ID, instead of A, I am taking like this 1001. Then I have customer ID is equal to 101. See, it's my practice to give space between the just before equals and after equals, or just before operator or after operator. It enhances readability of the program. That's the only thing. It's my practice. It's not hard and core rule, but it's always a good practice to follow it. Bill amount is equal to 199.9. Then I'll have print. I must have bill ID. Bill ID is since I don't have the values to be displayed at the in between to use %d, I can just use comma here after a double quote. If I do this, what happens is after printing the string, the value will be picked up after the comma. So I can just give bill ID here. This is same as writing print customer ID %d. This is same as this space % customer ID. Both the same, right? You can eliminate this %d, write comma, then customer ID, since it is at the ending. But if you want this bill ID to be displayed somewhere here, bill ID and then something else in between the string, then you must use the format specifiers. Only if the value to be displayed at the end of the string, then you don't have to use a format specifier. Print bill amount is rupees. Bill amount. So it's the same thing. I am using it in two different notations. The first line and the second line follows one notation. Third line follows this middle line follows another notation. Different ways of printing values. That's all. See, bill ID 101, customer ID 101, bill amount is rupees 199.9. So I got these values. So let's move on. Then comes the reserve words, or what we call as keywords, in other words. So these are the words which are meant to do some kind of activity. For example, Boolean here, false here gives the Boolean value of false. Instead of using 0, we can use false, right? Then we have a variable, a keyword name called class, which is used to define a Python class. Finally, same as your Java's finally. Is, we will see how to use is. Return, same as your other programming's return. None. Seeing many of these keywords in today's and tomorrow's session, but basically to define a variable, or it can't use them to define. Then comes a statement. We have already seen statement is basically a unit of code that can interpret statements. In this case, I have 1, 2, 3, 4, 5, 6 statements, right? And operator, we will look at what are operators and mathematical operations, what are different types of operations that we can do. Few values are basically hard coded, or the magic numbers, the constants, right? So as a variables, you don't have to declare a variable. Data type of the variable can be picked up at the time of execution when you assign the value. You can't just have a variable called a. Like you can't just say, like, in C you have int a, and then you might not use it in the program, just declare it, right? You can't do that in Python. You can't just have a, right? It throws you an error. It doesn't know what a is. A variable in Python is declared when you assign something to it. At the same time, the data type will be picked up. If you assign a is equal to 0 or 1, variable called a is created, and one is a memory is created for it. A memory layout will be created. When you do a is equal to 1, a memory layout will be created. 1 will be assigned to it, and it will be called a. It will have some address, right? Now, this is of type integer. If you put it in double quote, it becomes a string. It takes it as a string. You don't have to worry about it. You don't have to tell which variable is string, which variable is not a string, which variable is integer, which variable is float. Basically, since the only way for declaring a variable in Python is by assigning value to it, that is the reason you don't have to give the data type as well. You can just quickly change the data type of it. I'll show you this. A is equal to 10. Variable a is created. It is of type int. Immediately, I'll do a is equal to 10. Same thing in string. And I will take type of it. It says str. I will repeat it with a is equal to 10 followed by a is equal to 10. Now, what if I do type of a? The latest type which was assigned will be picked up. A right now is of type str. See, right now it is of type str. So this is the thing. When you assign, automatically the program will pick up the data type of it, and it will sense that it is a variable. It checks against the variable name rule, that whether it is starting with a number and all that, it will check. And location and memory will be created for it. The value will be stored, and then data type of that will be mapped. Data type of the variable in Python, as I just showed you here, can change during the run of the program. That is, while you are executing, the data type of a variable can change automatically. That's why when it comes to data types of a variable, you must be extremely cautious in Python, because somewhere some kind of wrong assignment might lead you to change the type of a variable itself. So in Java or C or C++, you don't really have to bother about it, because in the beginning, while the compilation stage itself, you tell this is a variable, this is the type of it. When you are storing value to it, you always ensure that it is of that type only. But you don't really have to do that in Python. In Python, you are simplifying it. You're telling, you don't worry about it. You assign a number to a variable, I'll pick up what the data type is. You change the variable type, I'll change the data type. Not a problem. That kind of easygoing nature. It's not very strongly typed language, but some way it is very much an advantage. It eases of the programming effort, but you must be extremely cautious in terms of logical flaws, right? But when you're good at logic and when you're good at programming, that will inherently take care of it. That's where practice kicks in. You guys have to practice more in Python. That's when you will inherently, it becomes part of it. That knowledge becomes somewhere, it auto triggers. Autopilot fires. Okay, this is wrong. This is where I have to take care of the data type. That automatically will come. when you practice it, right? So this is of type integer, this is of type string, this is of type float. You can print all of them by comma separated. It prints all these values, right? Not a problem. So automatically the values data types will be picked up. Now, what are the data types in Python? There are data types in Python. Types are integer, float, char, string, and boolean. We know all of this. Char means one character, string means collection of characters, boolean is true or false, float is decimal value, and int is basically a number, right? So that's about integer data types. Moving forward, let's look at Python operators. What are the top type of operators that we have in Python? I'll quickly run through it, and some operations I will show it to you. We have wide variety of class of operators called arithmetic operators, relational, assignment, bitwise, logical, membership, identity operators. Many of these operators, especially arithmetic, relational, assignment, bitwise, this behavior is same when you compare it to other programming languages. There are some special cases. We would be looking at that specifically, and the other obvious parts I would be skipping. Okay. Now, arithmetic operators are obviously you have plus, minus, star, divide by, modulus, then something called as float division or truncated division. I will tell you what float division is. Then you have to the power of, that is exponentiation. You don't have to use POW. You can just give double star. So 2 double star 3 will give you 2 to the power of q. 2 cube, right? So plus as an arithmetic operator between numbers, I mean, can be used to add, minus to subtract, multiply to multiply, into to multiply, divide to divide, modulus to get the remainder. Then this is a special case which I would be telling you. This is called float division. That is, for example, here the example says 10 divided by 3. What is 10 divided by 3? 3.33333, right? So the floor division, what it does is it floors the number. So if you have any result, a divided by b, if you take, so if you take anything, it gives point xyz, right? P point xyz. It removes the decimal part. It retains only the before decimal point, whatever the real number you have, that will be retained. See here, 10 by 3 doesn't give you 3.333. It removes the fractional part. It retained only 3. And 10, the floating point it is, it removed, it just gave 3.0 just to retain the floating point operation. That's all. That, guys, is arithmetic operator for you in operators for you in Python. Moving forward, we have the relational operators. The relational operators that we have are comparison operators, basically the equal to, less than, greater than, less than or equal to, greater than, equal to, not equal to. Not equal to here is not just this. You can also use less than, greater than. A not equal to B. You can do this by giving, it's the same thing. You would have probably seen this less than, greater than, not equal to in SQL in your 5th semester. But if not also, that's fine. It's same as this. These two are similar, basically. Okay. So these are comparison operators. The return type of comparison operators you already know. It is true or false. Then we have assignment operators. Assignment operator is the equal to. Then you have arithmetic assignments, that is plus equal to, which is basically C plus is equal to A means C is equal to C plus A. Same thing for minus equal to, star equal to. For all arithmetic operators, you can do this in Python. One small peculiarity or speciality of assignment in Python is to be highlighted here is this. I can basically assign 3 variables at a time with the same name. For example, I can use A is equal to B with the same value. A is equal to C, B is equal to C is equal to 10. This creates 3 variables and assigns value 10, right? So you can't do this in other languages. You have to give A is equal to 10, comma B is equal to 10, comma C is equal to 10. But here you don't really have to do this, right? Assigning same value to multiple variables can be done. Then assigning values parallelly can also be done. A comma B comma C, if you have, assign it 10 comma 20 comma 30. This assigns 10 to A, 20 to B, 30 to C respectively. So basically here this line is same as writing this line. A is equal to 10 comma B is equal to 20 comma C is equal to 30. You can do it parallelly, parallel assignment also. So this is one small peculiarity that you can experience in Python with respect to assignment operators. And moving forward, we have bitwise operators. Bitwise operators are the logical operators that we know. The operations carried out between the bits of the numbers that you have, binary AND or XOR, ones complement, left shift, right shift operators. We can use these variables, right? They're very handy when you don't want to use arithmetic operators. For example, you don't want to use slash or into, you can use left shift or right shift, right? The same way, they come in very handy. You can use bitwise operators like this. Now, moving forward to logical operators. Look, logical operators are basically operators which gives you you can combine multiple conditional operators there, right? And they give you result as true or false. Logical operators in C, you can use and or, right? But here in Python, you don't do that. You use A and English word or English word, not English word. So basically, you can use A less than B or C greater than B, right? You have to give like this. The proper word or is the operator. So that's why and or are not are reserved words in Python. You can't use them as identifier names. This is interesting. Membership operators and identity operators. This is where we have some peculiarity. Not very, not all programming languages have these operators. Just give me a moment, please. We have membership operators called in and not in. Basically, it says whether same as your mathematical in operator. For example, let's say that there is a list of values 10 comma 20 comma 30. I can say whether 10 in this list gives me true, or I can assign this list to a variable called A. I can check 20 in A, it gives true. 40 in A gives false, because 40 is not in the value in the list. This list is like array, consider it like array only, just for now. I will clarify what exactly list is in the for the class. But there is complement of this in operator called not in, which gives the opposite result. Not in A. Since it is not in A, it gives true, right? It validates whether it is there or not there. In operator gives membership. So if in a group of or a sequence of values, if value is found, then it returns true, right? If not, it returns false. Then comes is. Is basically used to compare two memory locations. Before is, I want to show you something called ID. A is equal to 10 if I give. ID of A gives address of A, right? So if I give B is equal to 20, sorry, I use a space. So B is equal to 20. ID of B gives some other address. See here, 15071868586 is ID of A. 6016 is address of B, right? So this is address. Now is operator is used to check whether two objects have same address. So for example, if I do B is equal to 10, now if I give ID of B, can you see here there is a same address as in 150718586. This address is B address is same as address of A when the value of them is same. The thing is, in Python, it optimizes the memory location if the value is same. If you have two values, A is equal to some 10 and B is equal to 10, it stores 10 someplace, and unless the value is force changed, both values refer to same thing. As in A and B, both are addressing to the same value. Now, somewhere in the run of the program, I changed my B to 15. Then at that time, it removes B reference here. It creates one more memory, adds 15, and calls it B. Right? We don't know if there is any C which is referring to 15 also. That also will be taken care of. So when you want to check, in this case, if when you have both A and B pointing to 10, same memory address, they both are same variables. They both are same objects which are referring to same element, right? So I can use A is B. It tells true, meaning they both are same. A is not B, meaning they are same. They are not B, means they're not. It's not like they're not same, right? Now let's say C is equal to 20. I'll use. Let me give A is C. It says false because they are different. ID of C is different, right? Now, if I use A is not C, I get true because they're different. So that is basically identity operation. They're used to compare the memory locations of two objects. Whether two elements are referring to the same place or not can be verified by using is or not is operator. That's why when I was trying to comment, this is a demo program. When I wrote as a remark for in the show the comment, right? Is was highlighted in a different color to show that is a keyword, right? That's the reason it came. As soon as I commented it, it never took it as a keyword. I told you about ID, right? So ID is used to a built-in function where you pass an object to ID. It returns the address of that object in the memory, and it will be unique and constant throughout the lifetime of that object. Until that object is destroyed, that address will not be destroyed. The automatic garbage collection will come into picture when the program is destroyed. The object is destroyed, and it will collect the garbage. So that's the thing. So this is the same thing is operation that I have shown. See here, a is equal to 10 is given, and then b is assigned to a. If you look at the id of them, value before increment is giving same id because they both are referring to 10, right? And then I will increment b to a plus 1. A is still 10, but b became 10 plus 1, which is 11. At that time, if you look at the id of them, the id got changed because this is still pointing to 10. This is pointing to a new value called 11. So that's the id function for you. Type I already showed you. It gives the data type of the object. Then coding standards, I was explaining it to you in the run of the program. Control structures is there. This part, control structure, we will continue it in the tomorrow's class quickly. Control structure and function definition I'll show you, and then we will jump into the topic of Raspberry Pi, the structure of Raspberry Pi and all that in the tomorrow's class. So that's all I have for you guys today. If you guys have any questions, I'm open to take it. Over to Shubhashni ma'am.
Hello.
Hello. Yes, sir.
Yeah. Okay. Students, you can ask some questions if you have any doubts. Madam. Hello. Subhashini madam. Hello.
Hello. So
Yeah, you can
me?
ask. Yeah.
Yes. So one student has asked why is only Python recommended for IoT project?
See, it's not really like that. There are multiple languages which are recommended for IoT. There is, as far as I know, Scratch. You can go with Google's language called Go. The thing is, the IoT is coming up quite. The hardware is evolving. It's still in the phase of evolution, and something that can adapt fast to it is what is recommended. And Python, as I told, is quickly adoptable because it is open source. A lot of libraries are contributed almost on a daily basis by worldwide developers, because of which it becomes very easy to use Python, right? The same kind of approach can't be used. You can use C++ in Raspberry Pi also, but you will have some kind of struggle in it because the community is not oriented towards using it, because it will be little hard. Ultimately, Raspberry Pi or any kind of SoCs are computers. They process zeros and ones. They should be able to process any software that you install on it, unless they have kind of hardware limitation. So you can use different programming languages. As I said, Python and Scratch, Go, these kind of languages are used because they are community supported. They are very much evolving with the evolution of Raspberry Pi itself. Evolved into 5 generations. Within a span of 5 years, there were 5-6 different types of variations of Raspberry Pi boards. When these kinds of evolution happens with respect to a hardware, you want the programming or the way you want to interact with that hardware also to evolve, right? You want it to evolve so that you can adapt well to the changes that is happening. That way, Python is very much adaptable. This also
Yes.
applies to machine learning. Machine learning is coming up. It's evolving in terms of its usage. Too many new algorithms are coming up. Too many new processors are coming up. Many trivial things are already automated in terms of libraries. The same operation, many libraries are available which you can use because people are openly, enthusiastically contributing it to Python, and everyone are able to use it. Same task can be used in multiple. You can use. There are. I told no. Just GUI can be created using multiple libraries of Python. Like that is the community support. You can also support. For example, if you identify some problem, you are not able to solve it using an programming language. You can write your own library to solve it and release it into public, into Python, and eventually you can integrate it with the Python repository, and people will start picking it up. That way, Python is very much evolving to the time. That is one main reason why I think Python is very much adoptable or favored for IoT projects.
Yes, sir. Sir, and one more question is like, what challenges do we face in implementation of Python? Like
Implementation
challenges.
that's see, Python is implementing any logic in Python is not really hard. Logic building is hard, right? That is where your algorithm or usage of data structure comes into picture. That is where your practice comes into picture. Programming language is merely a tool for you to achieve, convert the logic what you have built in a way that your computer understands, right? So implementation wise challenges is probably you will have to, depending on the complexity of your logic, you might have to understand Python usage more efficiently, optimization. One more thing that I want to make note here is, look, Python is quite dynamic in nature. It takes a lot of time. When you talk about speed, it is always C that stands out, not even Python. So when you take C, you will have to hard code a lot of lines in order to write it. But in C, many things are taken on care of. In Python, many things are taken care of inherently. I don't think those kind of challenges you would face when you try to implement something in C. The challenges that you would face in Python would be same. But I think the challenge would be more towards building the logic, understanding the different interfaces, understanding different APIs, trying to optimize the values. For example, I was telling you about image convolution. If you can understand it, if you can comprehend it, if not, please go look at it. What is convolution? You will understand what I'm saying. You don't really have to build a convolution matrix on your own, right? For filter. Python, you just have to pass the parameter and takes care of it automatically. So like that, you might have to, depending on what library you are using, because the choice of libraries are more, you might have to understand the library what you're using very properly in order to be able to implement it. That, I think, is a challenge for you to use.
Yes, sir. So that's it for today's session, sir. The questioning, sir. Yeah.
Okay, ma'am.
Yeah, okay.
Sir.
Karthik, today per session, I thank you. Tomorrow we'll join at 2 o'clock. Students, don't miss tomorrow sharply. You should be at 2 o'clock. Probably due to network or maybe gadget issue, maybe 5 to 10 minutes, it varies. Please cooperate. Huh? And also
Thank
there
you
are
very
my
much,
network.
sir.
Yeah, thank you.
Thank you very much, sir. Thank you very much,
Thank you,
Sebastian,
sir.
ma'am. And thank you,
Thank you.
students. Have a good day all. Bye-bye.